Today our topic is good evening. Our topic is buffer overflow attack introduction. Buffer overflow attack is one of the most common and dangerous security vulnerability in computer system. It occurs when a program writes more data into buffer than it can hold. This extra data can overwrite adjacent memory location, leading to unexpected behavior, system crashing, or execution of malicious code. What is a buffer? A buffer is a temporary memory location used to store data while it is being transferred or processed by a computer system. Uh, an intermediate storage area between different components such as processor, memory, input, output devices, buffers helps in managing data efficiency by holding it until the system is ready to use. For example, when a user types data uses the keyboard and the input is first stored input buffer before the program reads it. Similarly, when the data is read from a file or received from a network, it's stored in a buffer before processing. Buffer are also used in stack memory to store local variables, function parameters, and return addresses. Since buffer have fixed size, they can store only a limit amount of data. Therefore, proper buffer management is very important for the buffer smooth and secure functioning of computer flows. What is buffer overflow? A buffer overflow happens when a program stores more data in a buffer than its allocated size. Since every buffer has a fixed amount of memory, it can hold only a limited quantity of data. As a result, important memory areas such as variables, functions, pointers, return addresses may be get overwritten. This can change the normal behavior of the program and may cause error. The unexpected results or system causes the overflow to insert malicious code or and take the control of the system. Buffer overflow usually occurs due to the poor programming practices such as not checking input sizes properly or unusing safe input functions. Types of buffer overflow attacks. Stack based attack. A stack based overflow occurs in the stack memory, which is used to store function calls, local variables, parameters, and return addresses. When a program writes more data into stack, buffer that can hold the extra data overwrites nearby memory location on the stack. Stack-based buffer overflow is one of the most common and dangerous types of overflow attacks because it is directly affects the program execution. Heap-based buffer flow. A heap-based buffer flow occurs in the heap memory, which is used for dynamic memory allocation during the program execution. The heap stores data that is created for functions such as malloc, calloc, and new. In this attack, when more data is written into a heap buffer than it has allocated size, the extra data overrides adjacent memory blocks. This can corrupt important data structures. As a result, attackers may manipulate program behavior, gain unauthorized access, or cause system crashes. Heap-based buffer flow attacks are often harder to detect than stack-based attacks, making them in a serious security concern. Here is an example for buffer flow attack. We use a character buffer of 10 and we gets the buffer printing the buffers return 0. How attackers exploit buffer overflow as attackers exploit buffer overflow vulnerabilities by deliberately providing very large or specially crafted input data to program. This exists inputs exits the buffer storage capacity and overflow into nearby memory location. By modifying the memory locations, attackers can change the normal flow of program by execution. They may insert malicious code or redirect the program to execute harmful instructions. Such as attacks are often detected because they exploit weakness in the program internal memory management. Therefore, protecting programs from the buffer overflow vulnerabilities is essential for memory system security management. Prevention of techniques. Programmers must also perform proper bounds checking before storing data in memory. This means verifying the length of input and making it fits in the allocated buffer. By checking limits, programs can avoid writing the extra data into unauthorized memory access. Finally, programmers should prefer using the modern programming languages like Java, Python, or C Sharp, which automatically manage memory and reduce the risk or buffer overflow. Following the secure coding practices regularly, testing and software updating systems can further improve overall security. In addition, modern security mechanisms such as address space layout randomization, ASLR, and stack scan rates should be enabled. ASLR randomly arranges memory allocation, making it difficult for attackers to predict the addresses. Conclusion. Buffer overflow attacks are serious threats caused by improper memory handling. Secure coding practices can significantly reduce this risk. Preferences. Operating system textbook and C programming documentation.